A very good evening to all of you. We welcome you to the special masterclass 14 of Practical Cities Initiative on the occasion of World GIS Day. Practical Cities is an initiative by a group of young practitioners aimed to start a dialogue around the urban renewal. Our vision is to have in practice a framework for making cities more livable and sustainable. Practical Cities has launched an initiative for students, young practitioners, which allows them, the shortlisted, to showcase their work on our platform. For more information, please visit the website and the social media handles. In the last masterclass, we learned about the contemporary landscape urbanization practices from Singapore with architect Mayura Patil. Today, we are going to learn something very different, something very interesting. Today's masterclass is on exploring the concept of data-driven cities through the lens of GIS and remote sensing. GIS, a popular spatial analytical tool. For this, we would like to invite Raj Bhagat sir. Welcome, sir. Raj Bhagat sir is working as a manager in Rose Center for Sustainable Cities program of WRI India. He has worked in various domains such as urban development, water resources, and transportation since 2015. He holds a postgraduate degree from Indian Institute of Remote Sensing and the University of Twente, the Netherlands, where his research was focused on Earth observation and GIS informatics. He holds a civil engineering degree from St. Xavier's Catholic College of Engineering. He has undertaken research around spatio-temporal variation and patterns of various geophysical and anthropogenic phenomena. Sir is also being involved in creating multiple models using machine learning and big data to predict the urbanization in India. His research in the field are used by the government across various stages like the state, local, and union government. And he's been assisting them to adopt the data-driven approach in their planning processes. His current portfolio of projects includes, but not limited to, understanding the characteristics of urbanization in India, their effects on ecosystem, automated system for monitoring quality and quantity aspects of surface water, and a tool for cities for water assessment. Thank you, sir, for accepting our invitation.
Thank you.
Okay, sir, to start with the conversation, I would like to ask a basic question, sir, like what we can interpret by the penetration of GIS2 and remote sensing, its utility, and the importance among the young practitioners in the present days. Sir, it would be great if you can even add like what are the key features and inseparable component associated with it. Over to you, sir. Thank you.
Thank you, Jimmy. Thank you so much for the introduction and also for inviting me over here. Presentation is visible.
Yes, right? It's visible. Sir.
Okay, great. Great. Thanks once again. Right now, we'll be looking into what we call as data-driven cities, where we talk a lot about how data can help in decision-making process in the cities, right? In the whether it is local governance or whether it is the state-level governance, how data can play a role. So I work with an organization called WRI India, World Resources Institute India. So what do we do? I mean, some of the folks might not be introduced to the organization. So it's a research to policy organization. So what we try to do is that we do cutting edge research, and then we take it to the government to get it implemented. I mean, if it is a good recommendation that we want the governments to follow, we take it to them. So as a global organization, actually, we, our operations are in more than 50 countries, and there are multiple countries that are having offices. And in India, we have 3 offices, and we constantly engage with at various levels of government, from the union government till the ward level committees, or or it can be NGOs who are participating at a very, very local level. So the kind of intervention, everything will be dependent on the kind of research that we do. And what we try to do is that we want to improve the livability in our cities. That is the biggest aim, you can say, for my program, which is the Ross Center for Sustainable Cities. So I mean, when we talk about livability, we talk about it from all the angles: environment, economic opportunity, and everything that is around livability. That is our primary target. And I specifically work in a particular team called geoanalytics in India. So our task is to figure out, the data and the data-related questions. So how do we answer questions around decision making and everything around that in a more objective way. What do we mean by objective way is that if I ask a simple question to each and every one of you, do you think that the vegetation in our cities has been decreasing, or do you think the vegetation in our country has been decreasing? So majority of people would say that yes, vegetation has been decreasing, because it comes out of perception. Nobody has checked it. It comes out of a perception that trees are being lost, etc., etc. So, but the fact, on the other hand, is a little bit complex, in the sense like the natural vegetation has been decreasing, but artificial vegetation has been exploding, and that itself is a problem. That's what we think about. That is the fact about it. My role is actually to bring the objective nature of objective stuff into the research. That is, what is happening, what has happened, and what likely is to happen, and thereby removing all the biases that we have that are inherent in our observations. So this is the vision for our program. So we want cities to make planning and governance decisions that are economically competitive, environmentally sustainable, and equitable through state-of-the-art data analytics tools and models. That's what my team's vision is. So basically, internally, we I support the multiple teams, and each team will have some kind of a project, and we bring in some kind of a research into it based on lots of this GIS and remote sensing data. So that's how things work. So this is our approach. So what we use is a lot of these remote sensing data, GIS tools, big data, and AI and machine learning tools on one hand. And what we do is, we build lots of research to understand what is happening, and we build a lot of prototype tools for the government to either visualize or to analyze or stuff like that. And we also build lots of scenario models. And also a little bit on policies and capacity building as well. So what we expect out of it is integrated planning and informed decision making. So our belief is that good amount of data, when it is being used, it will improve transparency as well. And one very important aspect that we always look into is that we don't want us to do it all. It's not like WRI should be doing it all the time, and we always expect independent future replication. That is, if we teach a particular city how to do it, we expect another city to emulate the success or the results of it. So with that, I'll go into the subject that I'm going to talk about today a little bit, which is primarily on remote sensing. I believe that we have a lot of urban development oriented audience here. So I think I thought it will be very interesting to talk about remote sensing a little bit. So even though our work, my work largely encompasses urban development, transport, and water resources, most of the analytics that you might have seen out of GIS usually talk about, pet shed or accessibility or that kind of transport models or something like that. But I thought it would be good to talk about remote sensing. So what is remote sensing? The word itself says everything about it. You stand far away from an object, and you're trying to observe about it. And remote, that's the word remote sensing. So so it could be anything. It could be coming from airplanes, it could be coming from satellites, whatever it is. So today's presentation, I'll just talk about just 3 data sources. So I just wanted to talk about those 3 data sources. One is Landsat series of satellites, which started in the 70s, but consistent data has been coming in for the last few years from that particular program. And there is this SRTM, which is primarily an elevation model, and Sentinel program is a European Union satellite series from which we can get data. All these 3 data sets are open, and today's applications actually will be based out of all these 3. So the primary softwares I use for These applications are ArcGIS, of course, to visualize at the end. I mean, we don't, I personally use a lot of programming, which is Python, and a particular interface called Google Earth Engine, if you are not aware of it. Google Earth Engine is an open source. It's not an open source. It's a freely available, a cloud-based application where you can analyze a lot of remote sensing data. And right now it is free. So I think, anyone can try it as long as you understand a little bit of JavaScript or Python. It should be easy kind of thing. But it is very, very, it has become very important these days. And the way it can scale up, it is simply fantastic. So going into some of the applications out of these remote sensing data, I'll just talk about a little bit. So the first thing that we want to know about our cities is that where are they growing, when are they growing, and how are they growing, right? So these are the questions that we want to answer. So as I said, there are so much talks about subjective interpretation of the subject, and people say that these places are growing, that places are growing, but we want to verify it through data, through what is observable from the satellites and everything. So from that perspective, I'll begin the presentation on the application side. So this is as I said earlier, we use a lot of data from this Landsat resource. So Landsat program, it allows you to do a lot of the historical analysis. And what we did was, using those images, we tried to figure out how much of the area is built up in and around our cities. So how do we do that? How does this entire machine learning and everything works? So a little bit we need to understand about the process of machine learning is critical. It is not very different from the natural learning process. So for example, if you are say if you are having a kid and you want to teach them the different types of fruits, what do? Like, you take an apple and you show the kid that this is apple. You give them samples, right? So you show them this is an apple, this is how an apple looks, and you tell them that this is an apple. And then you show this is an orange and this is an orange. That's how so the kid memorizes by looking at certain parameters, like for example, the color, the shape, or the size, etc., etc. The kid looks at that, and the kid remembers that this is apple, this is orange. And if you suddenly show a new fruit, the kid will not be able to identify it, and it might associate it with either apple or orange or whatever it is, based on whatever it is seen. So the machine learning process is no different. So what we do is we feed those satellite images to the machine. We give them some samples. We say them that this is a building, this is a tree, this is an open area, this is a water body, etc., etc. This is snow covered area. So we give them samples for it to learn, and then we tell them that what are the parameters that it needs to look into it. Like, it could be shape, it could be size, it could be those kind of parameters. We feed in all of those. So when we do that, what happens is that the machine learns it. That is the process of machine learning, and there are many algorithms for doing it. Right now, it has become so easy that it is just a single line code. And after that, it learns that this is the thing. And after that, if I supply the entire satellite image to it, not just a sample region, samples could be like 1,000 pixels or something like that. But you have 1,000,000 pixels of satellite images. So now when I give the entire 1,000,000 pixels to it, it says that this is resembling urban, this is resembling water body, this is resembling green area, etc. So this is how we come up with all these classifications, and this is a relatively easier method. So using that, we began monitoring the entire urbanization process in the country, and you can see some statistics around the top 18 cities. What we did, we scaled up, and you can get the numbers around it. So, and in the left side, you can see a map of Delhi. You'll now notice that in which year, which area has been growing and which area has not been growing, etc. And you can see that around 2000, Gurgaon was growing more, and in 2010, Noida was growing more. So these kind of this helps the decision-making process. Now they'll know where and when. That's so the same thing. What we did was we scaled up for the entire country, And these are the results for the top 18 cities between 1990 and 2015. So you have maps on when, where, how, etc. I mean, what is happening, etc. So all the major cities like Delhi, Mumbai, Kolkata, Chennai, Bangalore, Hyderabad, everything is covered in this one. So now we have an understanding of how it is growing and where it is growing within a 50-kilometer circle, whether it is within the corporation, whether it is within the planning area, planning jurisdiction or not, etc., etc. Those kind of numbers we were able to produce because it's key to the planning process. Now let's take another step. Yeah, we understood where and when it is growing, but what is the driving force? What is happening to it? So to understand that, what we began doing is we wanted to classify the entire urbanization process into roughly into 5 classes. One was more of an urban extension where you talk about sprawl and infill, that kind of a growth, or second could be the strategic projects. It could be an SEZ, which can randomly come up in certain places. I mean, it depends on the policy making done by the government, or it could be an airport or something like that. And then you have corridor-led growth, which is a highway. And because of the highway, along the highway, there will be growth. And there will not be a proper network or whatsoever around that. And then the fourth is neighboring towns. That is, a big city is there, and because of that, a neighboring smaller town is getting, growing. It might be just those people who are living over there and going to work in the bigger city, or it could be another way where you have a lot of economic activities because of this. For example, in that snapshot, what we have is Bangalore and Hosur. Hosur is across the border, and because a big city is there near it, and Hosur, which is in Tamil Nadu, so it is benefiting a lot because of the growth in Bangalore. So that is one. And the fifth one is some kind of a random, built-up growth. It could be happening anywhere. I mean, in the middle of a farm or something like that, people decide to build a house or something like that, which we are not able to put into one category. So for that, we created all these 5 categories to figure out what is it. So now when I showed you these snapshots, you are able to see it with your own eyes, what it looks like, right? So these are the samples. And what we did was we began feeding those samples to the computers. We began providing hundreds of samples for each city. And what we did was, so since this is how it looks, try to figure out which are the places that come under each category and what is the share in each city. So we did that for the entire country. And the results are over here from Delhi, Mumbai, Kolkata, Chennai, Bangalore, Hyderabad. I'll go into what do these colors mean, but we were able to generate all these maps. And so here's the share proportion. So the red is supposed to talk about sprawl and infill, and yellow is about expansion of nearby towns. Blue is strategic projects like SEZ, etc. Corridors is the highways, and the pink is others. So you can see that the proportion changes between cities. It's not like there cannot be, I mean, the insight that one can take is one single policy cannot address all of these. And each one is for very, very different category. In case of Mumbai, if you look at it, not even, only 4% was just urban extension. And majority of it was going into the expansion of nearby towns. It could be Kalyan, Dombivli, Ulhasnagar, or Vasai Virar, or Panvel. It was the neighboring towns that are growing. And the main MCGM has been somewhat stagnant because of the geography as well. And in some cases, like for example, Surat, you have 38%, which is coming from strategic projects like SEZs, SEZ-led growth. You have SEZs, and because of that, the built-up area was increasing, etc. And in some cities, the corridor-led growth has been really high. So these kind of parameters we wanted to look into. So we were able to get this insight. So it was able to tell us where, now it is urbanization, where it is happening and what is leading its growth, and what you should be ready for in that particular city. Now, this is all fine. Now we understood the process behind it. Now, the major thing that when it comes to planning is that what about prediction? What about where does it go from here? So now that we know the combinations that are driving it, we decided to talk a little bit more. Sprawl and infill primarily depends on the natural growth as well as the economic growth of the cities. Same goes with the expansion of other towns. But when it comes to strategic projects, we need a list of strategic projects. So what we did was we began getting all the planned areas that were coming up, or all the planned SECs and other, a new airport or a rapid transit system or something like that. We began taking in all of these information and we began feeding it into our model. What it learned so far was that, what kind of urbanization is happening. Now it began saying that if these are the factors, then what is the chance of it being urban in the future? So we began going into that next level. So again, it was built in Python. The historical study was done in Google Earth Engine, and then we began doing a Python-based output. So this is 2019 urban area in Delhi, and considering the current projections, current expectations, the 2030 urban area would be looking somewhat like this. Primarily, as you can see, that primarily it is led by sprawl and infill. And of course, the cities of Gurgaon and Faridabad are the places where it is happening, not the NCT. You can see that NCT is somewhat stagnant, but when compared with the other cities. So by 2050, it is a very, again, it's the only limitation when it comes to these kind of models is that we are talking about the current plans and the current growth rate. I mean, for example, impact like COVID or something like that is not taken into account normally, or the current economic downturn, I'll say. So that is not taken into account, but this is business as usual. So if things go as usual, this is how it is going to result in. If we think that the other scenarios exist, we can always talk about it. We can tweak it. But yeah, right now, I mean, this is what we wanted to. I mean, this itself is a huge step for our governments. So that is where we are right now. Now, when we talk about all this urbanization and everything, we always want to talk a little bit on the environmental aspects of this kind of growth. And in the past, as well as the current, we have been making inferences on certain things like vegetation, temperature, etc., etc. Now, in particular, when we talk about urban vegetation, we talk about it as something that will offset the offset the effects of urbanization. That is, we are not looking at it as a replacement for natural vegetation. We are looking at it as an offset for our impact. So because in natural vegetation could be different. I mean, natural vegetation depends on the geography and the climate of the region. It could be naturally, it could be low, it could be high, it depends. I mean, cities like, say, Kochi might have a higher amount of vegetation, higher chances for having higher amount of vegetation, but a city like Bangalore or Hyderabad, they are not supposed to have that much amount of vegetation. I mean, that also creates a problem. So to avoid that, what we do is we don't talk about natural vegetation. I mean, within cities, it is very difficult. So what we think about when it comes to vegetation is to something that it is an amenity that it will offset the effects of urbanization. That's where we are coming from. So again, using the same Landsat series of satellites and Sentinel series of satellites, what can we talk about vegetation, right? So here's a sample for Mumbai, what is happening in Mumbai, and you can see that there's a map of Mumbai. Actually, it was just, we created this particular visualization last week, but even though the methodology has been around for some time. We wanted it to be correlated with surface temperature because, we wanted to see which are the wards which are doing it poor. We wanted to figure out the road areas where we can improve vegetation and that kind of, I mean, we have lots of these highly asphalted or concretized sections. We wanted to figure out all those sections where we need to improve vegetation. So for example, so what we did with Mumbai, you can see that there is a inverse correlation between surface temperature and vegetation. The wards which are having higher amount of vegetation were having lesser exposure to surface temperature. So surface temperature is the skin temperature. It's not the same air temperature. It's, I mean, a tar surface will be hotter than tree surface during daytime. Right. So that kind of we wanted to figure out those kind of things. So we used satellite images again over here. So how do we do the surface temperature? So surface temperature, here's the result from Bangalore, for example. Surface temperature is I mean, some of you might have seen in some museums or probably or even in video games where you talk about thermal infrared, where a body heat comes out of it, and we observe the heat, and based on that we'll infer what is the temperature. So the same things we do with satellites. Thermal infrared bands are there, and you can always play with it. So using those calculations, we have arrived at the surface temperatures in our cities. So this is a case for Bangalore. You can see some of the, the hot spots, blue are cooler spots, etc. And in the left side, you can see that, particularly zoomed into a smaller location, and you can see that, places, well-planned areas like Langford Town or Jayanagar have a lot of greenery, and because of which the temperature is lesser. But organically grown place like, say, Kalasipalayam has a higher temperature because of less amount of tree-lined avenues and stuff like that. And also the households are, you don't have much space. People don't have trees within their houses and that kind of situation. And then you have some kind of a big infra, like bus depot. Bus depots are one of the biggest hotspots in the city. All these major transport related ones, because you have lots of this asphalt and concrete flooring, and it doesn't have much green in between. Because of which bus depots, airports, big railway stations, all of them are big hotspots. So in the map also you can see that I have marked Old Airport. You can see a big red area. Apart from whatever is open ground or a rocky surface around Bangalore also will be hotter, of course. That's a natural one. But we do increase using our own tar and as well. So anyway, that is we wanted to figure out which are these hotspots and where we want to intervene, because it talks about heat waves and everything. When we are talking about all these things, we need to know who are the people who are vulnerable to it. It's not like the entire city of Bangalore needs it. I mean, Jayanagar doesn't need any of the major interventions. It is the people who are living in Kalasipalayam, they need interventions. Now we will talk about where we can put these interventions. If you want to intervene in these temperature or vegetation, where do we want to focus? So that is the second. And the next one is talking about, when we are talking about urbanization, we need to talk about surface water, where it is coming from. And so I have added a small slide over here, which we did for Bangalore, talking between, 25 years of how water bodies have changed over time, and where it has increased and decreased. So overexploitation has led to the decrease of water extent outside the municipal corporation, but inside the municipal corporation we don't see much of a decrease. The reason being is it is being now fed with sewage water, but sewage water also affects seasonality and things around it, but the quality, of course, but untreated sewage in particular is a problem. But we wanted to figure out which are the ones which are not, we wanted to differentiate which are the ones that are fed by sewage and which are the ones that are not fed by sewage. If a city is growing, so this tank, the lake, lake culture is pretty much there in South India, not in cities like Delhi, which are not dependent on lakes. But cities like Bangalore, Hyderabad, etc., Chennai, they are dependent on these lakes. All these are artificial lakes anyway, but still they are dependent on these lakes. And unfortunately, when the city expands, these are getting overexploited. And also when agriculture also expands, it's getting overexploited. We wanted to figure out where it is happening, etc., because it talks about the security, water-related security for the city. Since majority of the people are dependent on groundwater or self-provisioning methods, we need to look at these. Unless piping is not there for every citizen, right? So from that aspect, we began looking at surface water. It is the same methodology, but instead of built up, we are looking at surface water now. So it is the similar methodologies and that kind of thing. So then we began, talking about what if there is more water. We can talk about what if there is less water and what if there is more water. So there are two types of flood conditions. One is fluvial and the other is pluvial. One talks about riverine flood conditions. Say, for example, if you are in a city like, say, Patna or somewhere, it is not the local rain that is causing floods, but it is the river that is causing the floods, or Surat, or those kind of cases. Or if you are talking about the urban flood conditions in big cities like Bangalore, Hyderabad, etc., like what happened in last month, those are primarily because of the local rainfall. or in a very smaller region. It might, it might have a smaller stream and everything. It's all interrelated. So what we did was we began using all the elevation models, and we began, monitoring flood is one aspect that can help, rescue and rehabilitation. But what about finding out places that are vulnerable to it? So we began, simulating based on rainfall events and of the past, as well as, the future scenarios, whatever we think are possible in the cities. So we began simulating which places are vulnerable to it, etc. For example, in the left side, you have a flood simulation for Kabini River in Karnataka. What happens if 2 lakh cusecs of water is opened in the dam? What will happen to it? And in the right side top, what you have is during 2019, there was a flood event, and it was 1.4 lakh cusecs was flowing on that day. And you can see it's almost similar. I mean, our model results and how the actuals are there. And we wanted to emphasize this because during the, you can see that 2 of the flooded areas in that map correlate with 2 highways which were also closed in, as seen in Google Maps. So, placement of infrastructure in floodplains is another big problem. I didn't add a slide on urban flooding, but we have prepared maps for Bangalore. We are currently doing it for Mumbai and Kochi, where we are looking at flooding events, etc. So these ways, I believe that there are lots and lots of applications, scenario building, and so much of things that can be done with remotely sensed data. That is, going forward, the biggest impact that comes from out of these kind of analysis is that your decisions are not going to be, subjective. You are not going to come with your biases. What we are going to have is more or less on the objective side of things. I mean, what is happening, what has happened without, I'll keep my bias in my table and it will not come into the picture. Of course, we'll talk about the presence of bias within the data also, but at least it is measurable, and we can correct it to some extent. But personal biases, if it comes to play, it's very, very difficult. That's what. So anyway, that is our work right now, and yeah. So thank you.
Thank you so much, sir. It was very interesting part. Sir, I would like to ask some couple of questions. The presentation was very insightful, sir. Sir, my first question is like, where do we see the predictive modeling and in the coming days, like, because like no doubt it's a predictor, it's not able to capture many of the parameters. For example, like going specifically, you shown like which are the areas which may be developed in the coming years, like in your analysis, like the urbanizable area. But sir, like most of the time it is a political decision, like, and it's not based on the past trends, like, so how can we make it more holistic, like, uh, that was the first question, sir. Yes, sir. Over to you, sir.
So the first biggest application that we see right now is whatever is happening with the urban floods, for example. So already cities like Chennai and Kolkata have developed models for them, with respect to predictive modeling. Even though they are in testing phase, but they are still there. They have already reached that. Mumbai is following suit, and that is one place where we are seeing a lot of potential. If you had asked me the same thing 5 years ago, the same problem comes into play. There is politics, and politics. And there is a huge amount of unelected bureaucrats who are sitting over there and taking decisions, and because of which it is always having some kind of issues. But 5 years ago, yes, predictive modeling for floods also was not there. There was no scope for it. But now I see it in 3 cities, and it can become like a common thing in, like, say, 5 years. So the same story is going to happen with the predictive modeling on urbanization as well. But unfortunately, the biggest obstacle is not politics with respect to it, but with respect to the technology, as well as the people who are building these use cases. I haven't seen much work, quality work, good quality work when it comes to this. So it cannot be only WRI doing it, right? If it is WRI alone that's going to go into it, then it's not going to be very popular. So I mean, our reach is up. I mean, we do have good connections, but it doesn't mean that we can reach everywhere, everyone at the same time. So the resources to produce that quality results are much less in India, and that is the biggest obstacle I see. I mean, if it is usable, of course, many of them will integrate into their planning policies. But you need to have one thing that worked in WRI India is that we had a good understanding of what is happening on ground as well as the technology. So you need to have both. So only then a good quality model can be built. So if you are lacking on either, then of course, I mean, you'll have a set of programmers. You will end up with a useless model. If you are having just urban planners, you will never have a model. So that is how it works. I mean, you need to build up both together, and that's what WRI India did well. But yeah, I believe that, I mean, in the coming days, I mean, we need to build that up. I mean, the resources have to be there.
Yes, sir. Because if we see like there are certain models like Cityscope by MIT Design Lab and Urban Footprint are very popular outside India, but they are yet not started or either in a very preliminary stage. Like, thank you, sir. Your lecture was very much insightful. Like, please, if you please comment anything which you want to.
I'm pretty much honored to be here. I'm pretty happy also. Um, in fact, the moment you had shared that I would be doing it, I got a lot of messages after that, and I was like, okay, this is good. I mean, I see a lot of people who have subscribed to your ideas and your CVs as well. I'm pretty happy to see that, and I'm pretty happy to see the passion behind the subject. And that's where the step number one is. One has to be passionate. I mean, the knowledge for knowledge is something that we can build secondary. I myself, I'm not a computer programmer by profession, right? So I had a civil engineering background, but anyway, programming was something that I learned, and same way goes to GIS and remote sensing. So these are like something that I developed. GIS, of course, I mean, that goes longer, but still, the passion should be there. That's where the key is. And I'm happy to see that you have a good amount of people who are really passionate about the subject, and really interesting to see that they are there during the presentations. I mean, you can't make me sit through many of the presentations, or lot of the time. But even during this time, when you're able to bring people in, that means you're successful. That's pretty good, and I'm wishing very good luck for the initiative, as well as very good future for whoever has subscribed to the initiative.
Thank you so much, sir. It was very insightful, and like I guess like many people had a great learning from it. Like, and thank you again, sir.
Sure.
Uh,
Thank you.